Hello pre-calculus students, we continue our exploration of series with finite geometric series here, and the two key words here are finite, which means where there is a limited number of terms. Okay, the number might be very large, but there's a limit to how many terms we can have. We'll talk about infinite series in a little bit, and it's geometric, which means that each term changes by a ratio. So I'll give you an example. What if I asked you to add up all of these numbers? 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16. And you can certainly take out your calculator and add these up. Okay. The reason that this is finite is because there are a limited number of terms. In this case, there's 1, 2, 3, 4, 5 terms. The reason that makes this geometric is that each term here is being multiplied by the previous one. So 2 times 1/2 gives you, 1. Forgot my numbers there. This is 1 times 1/2 equals 1/2. 1/2 times another half equals 1/4. 1/4 times 1/2 equals 1/8. So just to review, the explicit definition in this case would be that a sub n is equal to 1 times 1/2 raised to the n minus 1. Okay? So we're repeatedly multiplying the previous term by 1/2, and then we're adding them all up. Okay? Now, and you can certainly add this up and get a number for the result here. But what I want to do is expand this idea here and develop a general definition. So let's take a general definition, and I'm going to use sigma here to represent the variable for the sum of a geometric series. And this is equal to the first term plus the first term times the ratio plus the first term times the ratio again times the ratio squared. So this is the first term, this is the second term, this is the third term, all the way up to the last term. So a times r to the n minus 1. And I want to see if I can find a formula for doing all of this quickly. Okay, and to make this work, I have to do a little bit of a trick. And so I'm going to create a new sequence here, or a new series, by multiplying all of these by r. So I'm going to call this r times sigma. And all that's doing is taking all of these terms that I had before, a sub 1, and multiplying each one of this by r. Okay, so a sub 1 becomes a sub 1 times r. A sub 1 times r becomes a sub 1 r squared, and all the way on down. So each one of these ratios increases its power when I multiply the entire thing by r. So this last one is going to be, instead of n minus 1, it's going to be n. Okay? And then the next sort of concept or trick is I'm going to subtract one of these series from the other. So I'm going to do the first series without the r minus the second series. And when we do this, you can see that I have a sub 1 here, so that's still going to be down here. And then I'm going to have a sub 1 times r minus a sub 1 times r, so these are going to cancel. I'm going to have a sub 1 times r squared minus a sub 1 times r squared, so these are going to cancel. And there's also an a sub 1 times r cubed within this dot 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 here. And all these are going to cancel. And the only thing that's going to be left is so this term here and this term here are the only two terms that's going to be left. And this is going to be a minus because I'm taking the first series and subtracting it from the second. So that should be a 1 there. Okay, so this is the result that I have. And from here, we just do a little bit of algebra. I'm going to factor out a sigma. So I'm going to factor this out, and that gives me 1 minus r. On the right side, I'm going to factor out a sub 1. This gives me 1 minus r to the n. And then to get sigma by itself, I'm going to divide both sides by 1 minus r. So I get a sub 1 times 1 minus r to the n, all of it divided by 1 minus r. Okay. And this right here is the sum of a geometric finite series. And we'll see a couple more examples when we can just use this formula right away instead of doing the repeated addition.